Assalamualaikum everyone. All right, I'm sure you have heard this since morning many times, but I would also like to congratulate you guys on being part of the LUMS family. And also welcome to LUMS, welcome to the School of Science and Engineering. All right. Of course, you guys are enrolled here in a sort of like degree program. So it's an academic institution. So you guys will be taking courses, theory courses, laboratory courses, and for that you will be solving assignments, taking exams, and all those things. But beside that, beside all those things, and perhaps more importantly, you guys will be making a huge transition in sort of like the way that you sort of like learn, the way you approach education. So purpose of education is going to change. So from previous sort of like purposes that you had, so study, you would get grades, here it's going to be slightly different. What universities do, universities actually train students, train the population that is existing on the campus to actually start being bold and daring and audacious enough that you could question the existing knowledge, to challenge the existing knowledge, right? And also beside that, it's going to help you, it's going to train you to sort of like learn how to go deep at the foundation, at the fundamentals of engineering and science concepts, and then sort of like develop, create, invent new knowledge, right? So challenge existing knowledge and ability to create new knowledge. This is what the purpose of university education is. This is what's going to happen here in the next 4 years of your education at LUMS. Now, when you're creating knowledge, so in other words, you're creating technologies and innovations, right? And for that, you need collaboration and cross-pollination among the discipline and between the discipline is extremely important, right? And that is one of the most important prerequisites to create knowledge, to create technology. And this you already might have sort of like realized during the first 2 to 3 sessions that we had. Now, so one of the outcomes of such cross-pollinations is development of plastics. So polyethylene. Polyethylene is the most common plastic that we all know of, right? So the chemistry, the chemical reaction, how to make polyethylene was actually developed by a chemist, but then its translation into real life, how to make plastic at a scale that now it is available to sort of like everyone, right? That's the engineering part of it. So the chemists develop the chemical reaction, and the chemical engineers, they take it to the scale, right? And you know that the polyethylene was actually discovered twice in the history. Not just once, it was discovered twice in the history. So first, it was developed by sort of like German chemists, but the synthesis was so sort of like difficult, so he was adding one methylene group at a time at the end of the chain to grow the long chain carbon of polyethylene. And the second, which is the most familiar chemical reaction, which we all know, that use ethylene or ethene as the starting material. This was developed later in the history. And this was developed at the ICI in the UK. And then the chemists develop their reaction, and the chemical engineer take it to the sort of like scale to make it available. Now the term plastic itself, it's not sort of like the polymers. So the polymer did not develop this term, or it wasn't developed for the polymer itself. Plastic has its own meaning, something which is soft, something which is pliable, something which is deformable. That's what was referred to as plastic. So because polymers had those characteristics, people started tagging them as plastics in general, right? Now, the first plastic was actually invented in 1929. So it's like less than 100 years back. So so there are so many plastic around us right now. I'll show you 2 examples. But what were people using before the plastics were invented? What were people relying on? Yeah, paper and clay, metals, right? So, sorry, wood, of course, right? So the point is that so there was the human already always needed materials, right? And we were relying entirely on nature before the plastics were invented. Now, so we were using wood, we were using something about we were using resins, right? Resins. So have you seen some gum oozing out of some of the plants? Have you seen that? So those are actually polymers, and people are using those gums like as sort of like insulating material. Right now, we have very advanced insulating materials that we're using, but at that time, those were the materials people were relying on. So the wood, metal, those resins coming out of the insects and plants. And even they were extracting horns of animals, right? And the dust to sort of like create materials which are as non-essential as billiard balls, right? So they would sort of like extract the dust to an extent that poor animal would die, and that actually triggered scientists to sort of like we have to come up with an alternative. I mean, this is not going to be sustainable. So this is what actually led to the development of this particular composite material, which is a nitrocellulose, which is based on nitrocellulose and camphor. Nitrocellulose was previously invented as a sort of like gunpowder, right? So they mixed them together and they developed a material which could be used to make billiard balls, so we could save the animals, right? Do you know that the first synthetic plastic was invented in 1905, and you have heard about it. This is phenolformaldehyde plastics, the bakelite. You might have heard about it in your previous sort of like educational trainings. So bakelite is the first synthetic plastic which was ever produced, right? And the target was, so there was the target here the scientists were trying to achieve. So we want to save animals because we don't want to make, we don't want to see animals killed just for the sake of billiard balls. And this, for the same, here, the target that the scientist Beckland was a Belgian chemist. So the target he had in mind was because at that time, the electronic industry was booming and they needed insulating material. And he was developing materials which we could sort of like help meet the growing demands of electronic industry. So these two sort of like inventions or these two discoveries had goals in mind, had targets in mind, what they want, what sort of problem they want to solve, what sort of technologies they want to save. But once we have the very first example of synthetic plastic in hand, people started sort of like studying more and more synthetic, exploring and discovering more and more synthetic plastics. And these are 7 of the most widely used, most common plastics that we have around us right now. There's polystyrene, PVC, nylon, the polyethylene, the bags one, polyurethane, the foams, polyethylene tetrapack, the water bottles, right? And polypropylene, the escape packet, right? Now, these new sort of like wonder materials, they started challenging the natural substitutes. They started challenging the natural alternatives. They started challenging the traditional materials, and they kept on winning the product after product, market after market, right? And they would replace metal, they would replace paper and glass for packaging. They would replace wood for furniture, right? So what was the reason for the success in adoption of these materials so sort of like quickly and so easily? They are more sustainable. Any other? They're cheap. Sorry, they're cheap. They're cheap. They are readily available, and they're cheap. Right? They're readily available in large quantities, and they're extremely cheap. Right? And they're cheap themselves, and they also help lowering the cost of development of other technologies as well. So that sort of like affected the whole technological sort of like boom that was happening around in that era. And of course, military superiority, I'll come to that in a bit. Right, so these are the reasons that these polymers were sort of like becoming more and more sort of like mainstream. Now, so it took about 22 years from 1907, it took about 22 years in the first polymer so the next synthetic polymer was actually came into the commercial production. It was polystyrene. So the first one was this phenoformaldehyde, this bakelite, and the next one, it took 22 years. But then in next 22 years, all of these 7 polymers were in the large-scale production phase. And then, if you look at the time frame here, the 22 years, and you coincide it with the World War II time frame, so it was military demand that was also sort of like spiking the need of sort of like materials to advance the military superiority. These 7 polymers here, you don't need to go into the details. And right now, according to the current data, there are 50 million tons each year. Collectively, these 7 polymers are being produced, 350 million tons. And these 7 polymers actually constitute about 80% of the total plastic production, total polymer production in the world. So these are the 7 sort of like, which we almost everyone who has interacted, even today, you'll see it. Right, so another interesting observation that I want to share with you guys is that this is how the world population evolved over time, right? So we are looking at this sort of like time frame, 1950s or so. So you see, it's about the middle of the 20th century, we can see the global population actually take an exponential rise. And that exponential rise again put a lot of stress on the natural resources, all those sort of like the woods and metal and all those things. Right? And that also gave an opportunity for plastics, so for polymers to thrive and sort of like increase their utility base. Right, so just to give you a feel that how much what is the extent of our dependency on plastics like in this current age, right? So look at this map here. So these are the submarine cables which are spread in the oceans across the continents. And they're actually enabling your communication through internet, through your telephones, and also even the TV transmissions that are happening at the speed of light. Of course, the major player here is the silicon, like optical fiber, which is helping the sort of like communication with the speed of light. But then what is enabling this all? So you are dipping it in the water at the bottom of the ocean. There's a lot of polymer plastic which is protecting, right? So this is our dependency. So imagine a world without internet right now. And even go to sort of like take a step back and look at the larger picture to see your mobility on land. You use cars, in the air, airplanes, in the water, ships, and then you go to the space. And all those things are using more and more plastics because plastic makes things lighter and increases the fuel efficiency and increases the distance that you can travel with the same amount of fuel. Your textile is all plastic, polyester. It's the same plastic, believe me, it's the same plastic which we use to make these bottles. It's the same plastic that we are using to make the polyester fiber for the clothing. So a lot of textile is plastic. Look at your kitchens, your paints, and other stuff. Look at the reverse osmosis membranes, those are plastics. Look at your mobile phones, they have those lithium-ion batteries, they're actually lithium polymer batteries. So they have lithium impregnated in a polymer, right? So it's a lithium polymer battery. So the energy production technologies, fuel cells, solar cells, your electronics, your flexible electronics, and there are other more advanced applications. These plastics being used here are not, they are a problem, but they're not as big a problem because they have a long utility life. The utilization is sort of like over several years, right? The problem is with the plastics, which we use just once. So we use the plastic and we just throw it into the sort of like environment. And these are originating from the hospital waste. So just imagine those plastic syringes used just once and then it's just thrown away. And then our sanitary products, all those sanitary products, even our masks, the mask that we are using right now, this is plastic. It's actually same plastic which is used to make the lace packets. It's actually the same polypropylene which is used to make your masks that we're using. And again, the other the food packaging. So we hear a lot of high and a lot of sort of like negatives about the plastic bags. It's not just the plastic bags. The problem is much larger than just simply talking about the plastic bags. And just to give you a feel of how large is the problem, so this is how the plastic production evolved over the year since the first plastic was since sort of like 1950s between till 2018. So see, conservative estimation, 6.8 billion tons of plastic has been produced today. 6.3 billion tons of plastic has been produced today. And you see, we talk about a lot of okay, let's do recycling, let's do recycling. You see, only 9% would be recycled. And this is just because of the technology that we are using that does not leave the plastic recyclable at the end of the life. So only 9% is recycled and 12% incinerated. There is about 5 billion tons of plastic that is either already in the environment or waiting to be in the environment. And that needs sort of like attention. Now, there are sort of like strategies people are using. As I said, that recycling is fine, but the technology that we're using to produce plastic products does not leave the plastic recyclable at the end of its life. So we need to come up with a better sort of like technologies where we could sort of like make our plastic products at the end of their life more recyclable, more reusable, right? And if we could sort of like make whole transition, whole sort of like economy as a circular economy where the plastic is being used and then converted back into the raw material, which is then used again to make the same plastic, and it sort of like goes on in the circle instead of sort of like accumulating in the environment. And then it's sort of like collective effort that's needed from different stakeholders. So the question, plastic villains or unsung heroes, it really depends on how we use them, what is our perspective towards them. Is there an alternative? There will be, but the alternative would only be successful if there are economic, technological benefits and also military superiority. Thank you very much, guys.